Hi, I'm Aishwarya. I'm going to explain my capstone project for the 5-day AI Agents intensive course with Google x Kaggle. The title of my project is Once Upon an Agent, a multi-agent storytelling system built using the Google Gen AI ADK and Gemini. It blends creativity, safety, translation, visual prompting, memory, and real time tools to produce adaptive stories for children. This project is submitted under the Agents for Good track. This project is developed for educational purposes to enhance immersive storytelling for kids and help them learn a new language. So, what's the importance of listening to stories? Well, children learn deeply when they imagine a world instead of passively watching it. Story listening activates the right hemisphere of the brain, which is about creativity, intuition, and imagination, strengthening core language and cognitive pathways. What are the challenges in storytelling? Despite its value, storytelling is not always easy. Parents are busy, safety is a concern, and basic chatbots can't maintain narrative continuity. Teachers also struggle to personalize stories for groups of children. Well, the multi agent storyteller is the solution. Instead of one overloaded model, I have used multiple agents, each dedicated to a specific task. This ensures safety, parallel processing, and consistent output. This is the workflow. The main agent runs sequential and parallel tasks. Safety comes first, then story generation and translation plus image prompts run in parallel to reduce latency. The time agent shows how agents can pull real world data. It enriches stories by grounding them in the current day or time. The check user prompt agent ensures the system never generates inappropriate content. It checks the user's input before creating a story. The story output is structured to be predictable, child friendly, and easy for other agents to process. Parallelism keeps the app responsive. Translation and visual prompt generation run simultaneously after the story is generated. The system uses ADK features such as context compaction, session persistence, and logging. Even when the kernel restarts, the story context is preserved via SQLite. If a child edits the story on the next day, the app remembers previous story elements thanks to persistent session history. This turns the AI system from a black box into a glass box. That is, we can clearly see why the check user prompt agent rejects or approves a user prompt. This architecture is reusable across edtech scenarios. It's both developer friendly and child safe. The possibilities for developing this concept into a product include fully immersive experiences such as scheduling, narration, and real time visual illustration. Okay, now I'll show the Kaggle notebook in which I developed the storybook app for this capstone project. It starts with authenticating the Google API key, importing the required packages for agents, models, MCP tools, and core applications, configuring the retry options, and defining the helper function, which is a run session, which asynchronously runs the runner. And after that, here's this multi-agent architecture with tools. So first is this time agent. It uses the MCP time server to tell the current time. So this is the MCP time server, and this is the function get current time, which gives the current time. And this is the time agent. It's an LLM agent with a light LLM, which is Gemini 2.5 flashlight. And this time agent tells the current time. So here are its system instructions to use the MCP time server to answer questions about the current time, date and day, and to mention the time zone in its answer. And this is the expected output format from this time agent. So here is an example. The current time in the time zone is time on date day. So this is the expected output format which is given as an example in the system instruction. This is one shot prompting. After that, the MCP time server and the time agent, they are created. And here is this check user prompt agent. So it uses a custom tool to check if the user prompt is none. So here's this Python function which is the custom tool, check user prompt is none. So it takes in a string and it returns a dictionary, and if the user prompt is none, it returns an error message telling that the user input or user prompt is invalid. And if it's not none, it returns a success status. So this function is used as a custom tool to this agent, check user prompt agent. So it's again backed by a light LLM, which is Gemini 2.5 Flashlight. And here are its system instruction to check if the user prompt is safe or suitable to generate a children's story. And it's given a hard instruction to reply strictly with one word, either yes or no. Yes if the prompt is suitable to generate a children's story, or no if the user prompt is not suitable to generate a children's story. And its response should strictly be either yes or no and nothing else. And it uses the above function, check user prompt is none, as its custom tool to check if the user prompt is none. And thus the check user prompt agent is created. And here's the story generator agent. So this is the creative engine. It generates a 7-page story for children based on user prompt, and it uses the same light LLM, Gemini 2.5 Flashlight. And here are its system instructions to generate a children's story with exactly 7 pages. And if it has information on the date, day or time, it should contextually adapt the story to the time. So here's an example. So if the time was 12 p.m. or 1 p.m., it could say something like it was a sunny Wednesday afternoon or something like that. So it could incorporate the time into the story. And to avoid negative themes, to teach the reader one scientific fact to be stated in page 5, and to introduce educational content naturally inside the narrative to ensure the scientific fact is accurate and written in child-friendly language. And so this is the output format being specified. So 7 pages, each page with 2 to 3 simple sentences. And here are some additional rules to use simple vocabulary suitable for young children. The theme should be positive and comforting, and to not add any extra text before or after the pages. So that's the story generator agent. And here's this image prompt generator agent. It generates a text prompt for image generation based on the first page of the story. It uses the same LLM, light one. And here are its system instruction to create one clear image generation prompt based only on the first page, page 1 of the story. So this is the image style. It should be animated with bright colors suitable for children. And this is the expected output format, image prompt followed by this agent's response and nothing else. And that agent is created. And here's this French translator agent. So this agent is created to help children learn new languages so that they can listen to the same story in different languages, so that they can make correlations and learn different languages. So French translator agent, it translates the story to French. It's created for educational purpose for the children to learn new languages, and it uses the same LLM. And the instruction is to translate the full story into French and while maintaining the exact structure and formatting of the story. Same goes from page 1 to 7, and here are the rules to keep 2 to 3 simple sentences, not to change the meaning, not to add additional sentences, and preserve the line breaks and the formatting the way it was in the story generated. And it uses Google search as its tool, so it's a built-in tool. So that's this French translator agent it's created. And here's this parallel agent. It runs the image prompt agent and French translator agent simultaneously as its sub-agents. And this is named parallel agent 123 because parallel agent is a keyword. That's why it's been named this way. And here is the main agent. It runs the time agent, the check user prompt agent, story generator agent, and the parallel agent in sequence. It runs them the above agents sequentially. So this is how the multi-agent architecture is being done. So this is the flow. It first tells the time, checks if the user prompt is safe and suitable to generate a story, and then generates a story, and simultaneously generates an image prompt and translates it to French. So that's the main agent. And now creating the app and runner with context compaction, persistent session service, and memory service. So the app name, user ID, model name, the LLM model name, they are initialized. Again, a lighter version is used. And an app is created with context compaction, so with the compaction interval of 1 to trigger compaction after every single invocation, and overlap size also being 1 to keep one previous turn for context. So this is context compaction is initialized. And here is creating a session service with SQLite, and to survive restarts, to retain the narrative flow even when the kernel restarts. And that's why database session service backed by SQLite file is being used. So to survive restarts, the database session service is used, and then a memory service is also being used to fill the context window. And now creating a runner with context compaction, with session service and memory service, a runner is created. And now the first iteration or turn 1 of running the runner. So here's how it's being run with the run session function. It was defined as a helper function earlier in the notebook. Runner, and here is the prompt: to tell the current time in Europe, London, and a story with unicorns, rainbow, and a parrot. And this is the session ID, which is app. So Gemini gets it, and this yes comes from the check user prompt agent. So yes means that the prompt is safer to generate a story for children, and it generates a story in the required format. It's in the same page 1 to 7, it's in the expected format. And after that, the image prompt generator also generates its response for image generation. And here is the French translation. So the task is carried out nicely. And here's the second iteration or turn 2 of running the runner, and having the same prompt with this to generate a story with the same theme, but with an eagle instead of the parrot. So the same whimsical theme is followed. It has the same theme of rainbows and unicorns, but there's an eagle instead of the parrot. So that's how the context is retained by the main agent. So in this way, children can customize the stories with the characters that they like or they find interesting. And here's the third iteration, turn 3 of running the runner. So this is to tell the time and a story that continues with the previous theme. So the agent, it has a sense of the previous theme of the rainbows and unicorns. So that's evident here. And then to check if it works the same way with a different session ID, to tell the time and continue a story with the previous theme. It generated a story, of course, but then it did not align with the previous theme. So it was some other different story which did not align with the previous theme of unicorn, parrots, and a bird. So session ID is it's quite unique to the particular narrative, and that's how it's done. Now checking the context compaction, the session exists, and totally there are 22 events, and while it checks for compaction events, there are no compaction events found. This could be because only 3 turns were done, only 3 iterations of user requests were handled, and therefore it's not enough or not sufficient to trigger the compaction event. So that's the reason why it's done. So multiple user agent interactions could trigger the context compaction. So that's how it is. Or maybe it did not work for this multi-agent architecture. And now checking the memory, uh, there's another session created to another session run, which is also appended, and then to check what the session actually contains, here's the user AI agent interaction. So so the memory has a sense of the user agent interaction, and it's been stored, and the memory service exists, and a story session is saved to the memory, and while testing the retrieval with a new session ID, it does not follow at all. So with the user's request being tell me my previous request, it's not able to follow up because this session ID app2 does not match with the session ID with which the previous iterations were carried out, which was app. So it says I do not have memory of the past requests, but still it has a hold of the story which was generated previously. And now to see how the database stores the session information. This is how it stores the iterations, the user agent interactions, and it stores the stories as well. Here's the another concept of agent observability, logging to get into the to check the thought process of the agent. So the plugin is used. So this is the prompt to tell the current time in New York and a short version of Harry Potter and the Chamber of Secrets. So it generates a raw response, but then the check user prompt agent responds with a no, which means that this particular theme is not suitable to generate a story for children. So that's what the check user prompt agent understood. So it's not ready to generate a story on this particular theme. So its response is no. Still, it delivers a story, but with a different theme, not with a Harry Potter one, but with a different theme. And now running the same thing with a different theme, that is to tell the current time and a short story with a dragon and a castle. This time the check user agent responds yes, which means that the theme of dragon and castle is suitable for generating a story for children, and it maintains that theme in the story generated as well. So there's this dragon in the story, and so on. So castle is also there. So this means that with the check user prompt agent responding with a yes, it's a green signal for the story generator to generate a story in this direction. Whereas in the previous case, it did not generate a story. So this is how logs can be used to find why the agent did not respond the way it's expected to, Maybe the user asks for a certain theme of story and the agent does not respond, and these logs uh, they help to look under the hood to see why it did not respond. So in this case the reason is the check user prompt agent, it responds yes or no, so it rejects or accepts the user prompt for uh, story generation for children. So that's how logging can be used to look into the agent's thought process and the flow.